I'm still in lesson 3.5. I'm doing these short videos in hopes that y'all can just watch the ones you need and not be bored by a big long video. But this example says 2 cosine squared x plus 3 sine x equals 0. And 0 is between x and 2 pi. And what we're going to do here is we're going to be using an identity to help solve it. Well, we're going to be better off if we can get only sines or only cosines in this problem. And I do know that cosine squared x equals 1 minus sine squared x. That's an identity. So I'm going to use that. I'm going to take the cosine out and I'm going to put this in its place. So it's going to say 2 times 1 minus sine squared x plus 3 sine x equals 0. I'm going to distribute, and I'm going to clean this up. It says 2 minus 2 sine squared x plus 3 sine x equals 0. I want to arrange it so that it looks like a quadratic. So it's going to say negative 2 sine squared x plus 3 sine x plus 2 equals 0. I want it to all be positive, so I'm going to multiply through by negative 1. 2 sine squared x minus 3 sine x minus 2 is 0. Then I'm going to factor it. Well, I'm going to factor, it's going to break down into 2 times the sine of x, and this one's going to say the sine of x. Factors of negative 2 are positive 1 and negative 2. I need to know which way to put them in there. This is like backwards FOIL. Factoring is trial and error. The method that's going to work is for us to put plus 1 there and minus 2 there. Then we break these apart. 2 times the sine of x plus 1 could be 0, or the sine of x minus 2 could be 0. Solving for sine, 2 times the sine is negative 1. Sine of x is negative 1/2. Sine of x is equal to 2. This equation has no solution, this part right here, because we know sine can never be greater than 1. So my answer is sine is negative 1/2. Well, sine is 1/2 at pi over 6, and that's going to be negative because it's y over r. It's going to be negative in the bottom two quadrants. So it's going to be pi over 6 here, which is pi plus pi over 6, which makes 7 pi over 6, and pi over 6 shy of 2 pi, which would be 11 pi over 6. Those are the two places where that's going to occur. So those are my solutions. What if they give me a double angle? It says cosine of 2x plus 3 times the sine of x minus 2 is 0. 0 is less than or equal to x less than 2 pi. Okay, the given equation contains a cosine function and a sine function. The cosine is a function of 2x and the sine is a function of x. We want one trig function of the same angle. This can be accomplished by using the double angle identity. Remember that cosine of 2x equals 1 minus 2 sine squared x. That's an identity that we're going to use in this problem. So we're going to put that in place of cosine 2x. 1 minus 2 sine squared x plus 3 sine x minus 2 is equal to 0. I'm going to clean it up. Negative 2 sine squared x plus 3 sine x minus 1 is 0. Multiply through by negative 1, 2 sine squared x minus 3 sine x plus 1 is 0. Now you're going to factor 2 sine x times sine x. Factors of 1 are 1 and 1. Both of them are negative in this case. The factoring rules apply from what you learned in Algebra 1. It's still going to be minus 1 and minus 1. Set these factors equal to 0. 2 times the sine of x minus 1 is 0. Sine of x is 1/2. Sine of x minus 1 is 0. Sine of x is 1. So, sine is 1/2 at pi over 6. It's positive. Those are quadrants 1 and 2. So it's positive at pi over 6 and at 5 pi over 6. So those are my two there, pi over 6 and 5 pi over 6. Sine is equal to 1 at 90 degrees, or at pi over 2. So pi over 2 is another answer. That's not going to work. The 3 pi over 2 is not going to work because it would make it be -1. So this has a solution of pi over 2. So those are my 3 answers there. Okay guys, I'm going to do one more and then we're going to call it good for this lesson. It's going to say sine x minus cosine x is equal to 1. And what are we going to do here? How are we going to get rid of one of those? Because for me to solve it, I just needed to say sine or I just needed to say cosine. I'm going to square both sides. When I square both sides, I'm going to have to use FOIL here. And I'm going to get sine squared x minus 2 sine x cosine x plus cosine squared x equals 1. I'm going to rearrange this. Sine squared x plus cosine squared x minus 2 sine x cosine x is 1. Well, remember, that equals 1. That's an identity from way back. So 1 minus 2 sine x cosine x is 1. I'm going to subtract 1 from each side. It's going to give me -2. Sine x cosine x is 0. Divide by 2. Sine x cosine x is 0. You divide by -2. So now you're ready to factor. Either the sine of x could be 0 or the cosine of x could be 0. Well, sine is 0 at 0 and at pi. Cosine is 0 at pi over 2 and 3 pi over 2. Now, because I squared both sides, I'm going to have to check these. I'm going to have to check them and be sure that they work in the original equation. Okay? Sine of 0. So I'm taking this equation, sine x minus cosine x equals 1. And I'm checking it at 0. I'm checking it at pi. I'm checking it at pi over 2. I'm checking it at 3 pi over 2. Got to check it at all of those. So at 0, sine 0 minus cosine 0, is that equal to 1? Well, the sine of 0 is 0. The cosine of 0 is 1. And is that equal to 1? No. False. So we've got to throw that one out. 0 is what we call an extraneous root. Can't use it. The next one, sine of pi minus cosine of pi. Sine of pi is 0. Cosine of pi is -1. 0 minus -1 is 1. Is that 1? Yes. So that one will work. Pi over 2. Let's check it. Cosine of pi over 2. I shouldn't have written that one. Sine of pi over 2 minus cosine of pi over 2 equals 1. Let's see. Sine of pi over 2 is 1. Cosine is 0. 1 minus 1 is 1. It equals 1. Yes, that one works. Checking the last one. Sine of 3 pi over 2 minus cosine of 3 pi over 2. Sine of 3 pi over 2 is -1. Since y is negative, sine is y over r is going to be -1. Minus 0. Is that equal to 1? No, it's not. So that one doesn't work either. So I only have two answers here, and that is pi and pi over 2.